In this video, we will do another linear approximation example. So I want to estimate e to the negative 0.1 power without a calculator. So to get this started, I need to find a suitable function f of x that will let me approximate this, and a value of a that's going to be close to the input that I need to evaluate this. All right, so for this function, I want to give you 4 minutes to try it. So pause it and try it for 4 minutes. 4, 3, 2, 1. Pause it and try it on your own for 4 minutes. All right, let's talk about it together. So for this value, e to the negative 0.1, I can think of two natural options for what to let our function be and what to let a be. So one is, I could let my function be e to the x, and if it was e to the x, well, the x value that we want to plug in is negative 0.1. So the value of a needs to be something close to that x value that I know how to plug it in and what I will get out. And I would say that a value is 0, because I know how to do e to the 0. That's just 1. All right, but there's one other natural option. The other natural option for this would be to let our function f of x be e to the negative x. If it was e to the negative x, then the x value I would be plugging in is positive 0.1. And the a value, the nice value of a, that I can plug in close to this, is still going to be 0. Because I know what e to the 0 is. It's just 1. So let's do option 1. But both will work just fine. Let's do option 1, but both will work. All right, so we need to find the equation of the tangent line. Find the equation of the tangent line. So to visualize this, let's draw a picture. So I'm going to draw some axes. And if I draw the graph of e to the x, that looks something like this. And we are interested in knowing, well, what's going on at negative 0.1? So at negative 0.1, here is the point. So this is the graph of y equals e to the x. And that is our actual point. And we are going to use a equals 0. So we're going to use 0 as our input. And that's kind of nearby negative 0.1. And I'm going to draw a tangent line through this point where x is 0. So that tangent line looks something like this. And with the tangent line, I'm going to now plug in negative 0.1 into that tangent line, and that gives me a point here, and that is my estimate. All right, so we need to get the equation of this tangent line first. So to do that, I need to know a point on the tangent line. Well, if I plug 0 in for x into this function, the y value is 1. So my point is 0, 1. And for the slope, I need to do the derivative of e to the x. So my f prime of x, the derivative of e to the x is just e to the x. And now let me plug in the 0. That's where we're taking the tangent line at. If I plug in 0, we get e to the 0, which is 1. So that's the slope of my tangent line. So we are ready to write down the equation. The equation is going to be y minus the y coordinate of the point, which is 1, equals m, my slope, which is 1, times x minus the x coordinate, which is 0. And I could simplify this. Maybe let me just isolate the y, and I'll get y equals x. Adding the 1, I get plus 1. All right, so I now know the equation of this tangent line. Next, I'm going to plug in negative 0.1 into the tangent line equation, because that'll give me this point. It'll give me its output, and that's going to be my estimate. So now let's plug in the actual x value into that tangent line equation. So we'll get y equals, plugging in negative 0.1 and then plus 1. That's 0.9, and that is my estimate. Looking at my picture, this underestimates the actual value. Underestimates the actual value. And I could see that because on the tangent line, this point when I plug in on the tangent line is lower than that corresponding point on the actual curve. So e to the negative 0.1, the actual value from plugging this into a calculator, this is about 0.9048 if I round it to 4 decimal places. So our approximation is pretty close. And notice that our approximation was lower than the true value. It does underestimate it. Okay, so I want to end this video with a note. So this note is about, well, how do calculators actually work out what something like e to the negative 0.1 is? So calculators actually use this general idea of approximation, but instead of using lines to approximate what's going on, they use polynomials. So higher degree polynomials to estimate things like e to the negative 0.1. When I have a function and I plug in a value into it, that's not nice. I can't evaluate this, just in my head. So specifically, these polynomials, they have a special name. They're called Taylor polynomials. So in Calc 2, polynomials. In Calc 2, you'll see these. You'll study these Taylor polynomials. So this is in Math 1B in Calc 2. It'll talk about something called Taylor series and Taylor polynomials. So this note is just a little bit of a preview. All right, in terms of our goals, we finished our first goal. We now know how to estimate functions at non-nice values using linear approximation.